In the previous videos, we looked at the foundation. So you got a basic understanding of what a blockchain is, how you can interact with it through transactions. We looked at smart contracts, and you even got a chance to develop your own smart contract. But now it's time to turn to an actual example of a vibrant ecosystem where these smart contracts are employed. What I'm talking about is called Decentralized Finance, or DeFi for short, and will be the topic for the remainder of this class. All right, let's get started with an introduction to decentralized finance, or DeFi. Now in this video, you should not expect me to go into any of the details. It's really just a high-level overview of the topic to build a common foundation, but there will be more specific videos later on, dedicated videos on various subtopics such as tokens, for example, such as decentralized exchanges or lending markets. And there we will really go into the details of these topics. But right here, this is just an overview, basically some information of what you can expect from the remainder of this class and what this topic is all about. The first thing we have to do is, of course, define what decentralized finance actually is. And this definition right here is based on a paper I've recently published with the Federal Reserve Bank of St. Louis, their review. And the definition goes as follows: DeFi employs public blockchain networks and smart contracts to build open, transparent, composable, and non-custodial financial protocols. So the idea is really that you use all of these technologies we looked at. So that we have a public blockchain, and that's super important. So one of these independent blockchains, not a corporate blockchain, not a permissioned ledger, a public blockchain basically as a settlement layer. And then you use smart contracts, like we have looked at, or like you've developed, to recreate many of these financial services in a different way. And in a different way really means that you can recreate them in many cases in a trustless manner. A trustless meaning, of course, you have to trust the math, of course, you have to trust the code, but it means that you can look at the code ex ante, so you know exactly what's supposed to happen. You have a transparent way of studying, of scrutinizing this code. And you basically have deterministic execution, a safe, immutable storage on the blockchain. But let's look at these four keywords. So the open, where is my cursor? Right here. The open, the transparent, the composable, and the non-custodial, one by one. And let me start by open. What do I mean by that? Open essentially means that by default there are no access restrictions. And it's important that there aren't any access restrictions on neither of the layers, and we will look at these different layers later on. So not on the blockchain. It wouldn't be good if there are any access restrictions on the blockchain. And there are special privileges on the blockchain, but it would also not be good if there are special privileges on the protocol level. So it really means that it's completely open, that you have this independent infrastructure that can be used by anyone, and that no one has special privileges, for example, that they can do things other people cannot do. There is, at least by default, no KYC, no whitelisting requirements, no minimum amounts, nothing like that. It's really just this independent infrastructure you can build on. And then the second part, transparent, means that everything that happens in DeFi, whenever you have an interaction with a smart contract, whenever there's anything going on really, then you can mathematically verify it. Anyone can mathematically verify it. So you see the code, you know what is supposed to happen. You can look at the code ex ante, so the smart contract code, and then you can verify whether it actually has happened. So all of the security guarantees we get from a smart contract, in combination with a public blockchain as a settlement layer, are intact depending on the implementation, of course, subject to the implementation, but at least in theory you can get these security guarantees and you can create something that is extremely transparent, that can be scrutinized by anyone. And then composability is usually described as Lego pieces. So where you have all of these different building blocks and you can piece them together and create something new. And the way this works is because, as you have seen in the earlier lectures, smart contracts can interact with each other. Of course, you need somebody who is initiating the transaction. So at the beginning, the initiator has to be an EOA, has to be an externally owned account. But then you have all of these internal transactions, you have all of these calls of other smart contracts. And in that way, you can have a basically a sequence where one smart contract uses a function of a different smart contract, where one smart contract builds on a different already existing smart contract, and that is usually referred to as composability. So to give an example, when you have let's say a decentralized exchange where you can swap token A for token B, when that is already in existence and you create a new financial protocol that may have a need to change assets as part of its own protocol, as part of its own contract execution, this new protocol, this new smart contract can rely on a decentralized exchange that is already existing to conduct these swaps. And that's something that allows, of course, for a huge amount of financial innovation that really allows you to interact with other smart contracts and have this composability where whenever there is already a building block in place, it can be reused by everyone else, by every other smart contract. And that's probably one of the main reasons why we see this massive speed of innovation in the DeFi space. And then last but not least, non-custodial, and that's super important. For many applications in traditional finance, you have custodians. So essentially you have a financial intermediary you have to trust. Basically you give that custodian your assets in custody. They are holding on to it. And the only thing you can do is ask whether they will release it back to you, whether they will send it back to you, but you're not in control anymore. And with DeFi, that's different. With DeFi, again, depending on the implementation, at least in theory, it can be coded in a way such that you will never lose exclusive access rights to your assets until the very last second when it's executed. And then, as you will see later on, there is a concept called atomic settlement, atomic transaction, so the atomicity that also ensures that you don't have any counterparty risk when it actually is executed. So long story short, the non-custodial requirement means that you don't have to trust any institutions. Yes, you have to trust the code in the sense, of course, you can look at it, but you have to check it for yourself when you actually want to know what it's doing. And yes, of course, you have to trust the math. Again, something you can check if you really want to, but you do not have to trust anything you cannot verify yourself. You do not have to trust, for example, an institution that they are not running with your money, that they are not messing up. Everything you have to trust can be verified by yourself. So you basically can check the conditions. You can make sure that all of these conditions hold. And that's something that's super exciting. The information is there, and then you can verify it yourself. And these are these four keywords. These are the four most important aspects to DeFi. This is what is different to a traditional financial system, because in traditional financial systems, in many cases, it's neither open. So the open part right here isn't really existing. I mean, there are so many access restrictions. It's also not really transparent. In many cases, it's really these silos where you don't have access to the information. You don't know exactly what's going to happen. You cannot verify it. In many cases, it's not composable because these financial intermediaries, they either use their own core banking systems or have a different interpretation of many of the parameters in there. There is little to no exchange between these core banking systems, and it's just in many cases a mess. And also in traditional finance, it's custodial. Most of the applications in traditional finance rely on the fact that you give your assets away in custody to someone else. And in many cases, you don't even have another option. So for many of the assets that exist in traditional financial markets, you will in some cases not even have the option to hold on to them yourself. Whereas in DeFi, it's non-custodial, meaning that you can always, if you choose to do so, you can always assume self-custody, and you don't have to trust anyone else. Now, what is it not? That's also super important to understand, because especially when you read articles in many mainstream media channels, but also from some people who call themselves experts on the topics, DeFi has absolutely nothing to do with, number one, CBDC, programmable euro, programmable Swiss franc, programmable USD. It's something completely different. I mean, CBDC can be interesting, but they're certainly not decentralized. They're not immutable. It's essentially just digital money that is issued by a central bank on a new infrastructure. But it has nothing to do with this decentralized, transparent way of creating financial markets. It's usually on a permissioned ledger and not on a public ledger. And of course, you have many access restrictions there as well. So it's something completely different that can be interesting, but it's not DeFi. And then, of course, when you're running DeFi in air quotes protocols on your own in-house blockchain. So, for example, when there is a financial intermediary and they are running some test cases and they're saying, yes, we also have our DeFi applications, it's on our own test network we're running in-house, then this is also hardly DeFi. I mean, when you have your own test network, when you have your blockchain that is under the exclusive control of just one entity, then it's the settlement layer is already heavily centralized, and then of course anything you do on top of that doesn't really matter anymore, so you can hardly call that DeFi. And then last but not least, of course, the same counts for heavily centralized settlement chains. This is something that can be also in the domain of the CBDC or also the in-house blockchain. But there are many consortia around the world where some of these financial intermediaries, they work together and they create their own permissioned ledgers, mostly for settlement, mostly for the issuance of various assets, bonds, for example. But that's also not DeFi. I mean, again, we have the access restrictions. Again, it's not completely transparent in the sense that just anyone can check whether it actually works out the way it is supposed to work. It's just, there are all kinds of privileges on there, and essentially it's just a regular database that gets recreated. DeFi is different. DeFi is based on public blockchains. DeFi is non-custodial, it's open, it's transparent, and these are really the things you have to look for. And that is what makes it special at the end of the day. And there is a place, of course, for all of these projects, but they shouldn't be referred to as DeFi. Now let's look at the DeFi stack. This is also part of the paper I've published a while ago in the Federal Reserve Bank of St. Louis review. They have proposed basically a framework, a model of how you can think about DeFi, of the various layers that exist within the DeFi ecosystem. And this is also super helpful to structure the class and to think of the different topics we look at in this class. So, I mean, we started with the settlement layer right here. And we've looked at, of course, the Ethereum blockchain, looked at the basic building blocks, made sure you understand how the blockchain works. We have also looked at the native protocol assets, so Ether, things like gas fees and so on. And the next thing we will do after this introduction is turn to the asset layer. On the asset layer, of course, you could argue that native protocol assets, so Ether, is also part of the asset layer. But what we will do in these videos is we will look at tokenization. So we will look at standards like ERC20 or ERC721, so standards for fungible tokens and non-fungible tokens. To give you a quick primer, a fungible token is something where it doesn't really matter which specific token from a class you have. So when you have, for example, a stable coin, let's go with that, where you say it's a US dollar pegged stable coin, then it doesn't really matter whether you have this specific one of this class of US dollars pegged stablecoins or another one. It's essentially the same. Whereas with non-fungible tokens, we are really talking about something that's unique. So it could represent, let's say, a painting or just something that really only exists once, and therefore it has a unique identifier, and therefore every single token is different. And that's the difference between these fungible and non-fungible tokens, and you have standards for both of them, and that's something we will look at the asset layer. Then we will go to the protocol layer. With the protocol layer, you really recreate these different financial protocols, these different financial services. So, for example, we would look at decentralized exchanges, we look at lending markets, we will look at derivatives, synthetics, and we will also look at asset management as some examples. So these are just some categories. And what's important, and this is also true for the asset layers, that everything you're seeing here, so be it these different tokens, the ERC20, ERC721, but also all of these protocols, everything is built on smart contracts. Everything is in fact one or more smart contracts. And we will also look at some of these examples, how these things are implemented. And then on top of that, you have two things I refer to as the application and the aggregation layer. So the protocols themselves, such as the smart contracts. And then on top of that, you have basically an application that makes use of these smart contracts. There is a gateway to the smart contracts. So you can think of it a little bit as a front end that makes the access to these smart contracts much easier. So a Web3 based front end. And with aggregation layers, you have can think of it a little bit like an online banking platform where some service provider, they aggregate these various smart contracts. They they build a nice front end that is easy for people to interact with, and make sure that in one nice dashboard you have all the information you need and you get access to these different kind of smart contracts, usually in a much more user-friendly and more convenient user interface. That's the basic idea. So why DeFi? What are some of the advantages? Of course, there are many advantages, but some of the things I want to specifically mention at this point is number one, in the traditional financial services world, what you're doing is you have to completely trust these financial intermediaries. It's a trust-based execution. Whatever you do, you usually already have the assets with a custodian, but then also when you, for example, give an order to do something, then you have to trust that these financial intermediaries are actually doing what you're asking from them. But you cannot verify anything yourself. You just have to trust that they did it. You have to trust that they are actually doing that on your behalf, and that they are not cheating. And that, of course, has several implications. And number one is that there are all kinds of audits, all kinds of regulations, all kinds of inefficiencies, because somebody has to take care, somebody has to actually verify whether you can trust these people. You cannot do that, but there are some certain regulators that will do that, and there are certain requirements. And that just makes the process in many cases cumbersome and also, you could argue, inefficient. Now, again, in theory, you have deterministic execution with smart contracts. Of course, when you do a sloppy job in implementing them, then there can be some errors. Of course, when there are all kinds of dependencies that are implemented, then it can also be trust-based, but there is a way for smart contract-based financial protocols to be completely deterministic, so that you know exactly what's supposed to happen, that you can verify everything, and that is extremely exciting. So at the end of the day, we're really talking about basic instructions that are coded in the form of smart contracts, and you can verify everything that happens for yourself. So second, in traditional financial markets, most of the infrastructure is built on really complicated clearing and settlement systems, where you have some financial intermediaries in between that take care of clearing, that take care of settlement. Of course, they will not do that for free because it's a service they provide, and they also have a place in the system because in many cases in traditional finance, nobody wants to make the first step. So let me give you an example. Let's say you have Alice on the left side, you have Bob on the right side, and they want to exchange some assets. Okay, so we have Alice has the A asset and Bob has the B asset. They want to exchange it. And in a traditional financial services world, what they would do is they would go to a financial intermediary. Both of them would deposit their assets with that financial intermediary or already have it there. And then it gets exchanged eventually. The financial intermediary in between would also take care, of course, of clearing. They would say, yeah, everything is fine. They would take care of settlement. And this is, of course, somewhat cumbersome. This is, of course, really expensive. Now, what you can do with blockchain-based solutions, and that's one of the main advantages of these blockchain-based financial protocols, is you can make use of atomicity, of transaction atomicity. So you have this principle of atomic settlement, where you have certain conditions that will only ever get executed together. So in this case, in my example, you could say, okay, you make sure that token A from Alice to Bob and token B from Bob to Alice essentially becomes one transaction. Of course, it's two steps. Of course, it's two individual steps that are part of the same transaction, but you make sure by creating an atomic transaction that these two steps cannot be separated. So you know exactly that token A from Alice to Bob and token B from Bob to Alice can only ever be transacted together as one. And that, of course, eliminates a lot of the counterparty risk with this trade, and is something that's extremely exciting and innovative in the finance space. And there are many of these examples that build on this atomicity principle, and that we will also look at later on, and that's a big advantage. And then the third one is in traditional finance, you see all kinds of silo services. So there isn't really any way of sharing information efficiently. There isn't really any way of interacting with the different core banking systems efficiently. There has been a concept that has been discussed for a long time. It's called open banking or open finance, where people are advocating for these open interfaces. And in some jurisdictions, this has already happened to some extent. Unfortunately, it's still a pain. And when you look at the infrastructure and the basically the legacy infrastructure that already exists in finance, then this is really no surprise. It's really cumbersome. It's hard to change anything. In many cases, you cannot really change anything because nobody knows exactly what would break, what would happen when you do change it. And of course, on the complete opposite, you have DeFi with this programmatic composability, where everything by default happens on the public blockchain, where everything by default is open and transparent, and where everything by default is completely composable. So you can basically have the sequence of various smart contracts that interact with each other, and everyone can just make use of anything that has already been out there. Okay, so whenever there's anything deployed, you can just reuse it, and that is extremely exciting. So these are just a few of the advantages. Again, we will tackle the various topics that I've shown on the DeFi stack in the next few lectures, but that's it with the first overview on DeFi. Now, as a primer, I recommend that you're reading the paper I've teased various times. It's called Decentralized Finance and Blockchain and Smart Contract-Based Financial Markets. You can find it online, and it will help you to understand the things that are to come when we tackle more specific topics in the next few videos. With that, stay curious. See you soon.